That's whatever is fancy. See.
Yeah.
We need a much darker pen.
Why is it so dark?
Yeah, I'm not getting one.
Let me get this.
Okay, Najib, we start. So we start by what you call a rational and irrational number. Rational and irrational number. Rational and irrational number. So when you understand rational and irrational number, then we can directly go to the Surds itself. But we need to understand what is a rational and irrational number. I will start with rational number. Start with rational number. And I want to assume, but I want you to assume a number like, assume we have a number like any number, we can say 1 over 5, representing it as a fraction. I mean a over b, representing as a fraction.
Yeah.
Where a and b we can say are integers. Okay, any number, a and b are integers, so that we can represent it as a fraction. So for example, I want you to take a number like 5, for example. I'm taking a number like 5, okay? Now, this number also I can represent it in form of a fraction by, for example, saying 15 over 3, right? 15 over 3 is the same as 5, right? By 3, 1 by 3, 5, right? Right? So we can say that 5 is a rational number. Okay? Why am I calling it a rational number? I can represent it as 5, and I can represent it also as a fraction, that is 15 over 3. So I can say that 5 is a rational number. Are you together? So a rational number, we can say, is a number that can be expressed. A rational number is a number that can be expressed as an exact fraction. As an exact fraction. As an exact fraction in the form of either a over b, where a and b are integers, right? Is 4 a irrational number? Rational? Yeah. Let me take 4, right? I can represent it also as a 12 over 3, right? So 4 is a rational number. I hope you have understood rational. Let's come to irrational now. What are the irrational numbers? I hope you are together with irrational number. Let's come to now irrational numbers, and we see what are the irrational numbers. So irrational number is a number that cannot be expressed as an exact fraction. You cannot express them as an exact fraction. Are you together? So examples of irrational number can be a pi, okay? It can be root 2. You cannot express it as a fraction, right? Another one, it might be also a number like the cube root of 5. These are called the irrational numbers. You cannot express them in an exact fraction. Are you together? It can only be given as an approximation to as many significant figures as possible. Okay? It can only be given as to many significant figures as possible. Are you together? But you cannot express. Do we have anything that will give us a root 2? We write it in form of a over b.
13 is a rational number.
13, when we have 39 all over 3, that is 13, irrational number, okay? right? Yeah.
Most of all of the numbers.
Most, yeah, but this one's the pi, right? Pi can appear as 22 over 7, right? And then it can appear as 3.142 into a significant figure.
Okay,
Got it now? Okay. I hope you have understood irrational number, right? Now I also want you to have the concept of recurring decimal, which you already learned it, The recurring decimal, I hope you remember, but I will make you remember. We have also recurring decimal. I also want you to remember this one, recurring decimal. And for the recurring decimal, I can have
1 over 3.
1 over 3, very good. When I have 1 over 3, then this will give me 0.3, right? But this 3 is recurring. So you remember we put a dot on top of it, representing recurring decimal, right? So even though they are non-terminating recurring decimal, you can represent them in fraction, that is A over B, right?
Yeah.
And you can represent them as an exact number. Are we there?
Yes.
Yeah. So we can say recurring decimal also are rational numbers, right?
Yeah.
Yeah, because you
Rational
can,
numbers, you can change it into
yeah,
a fraction.
yeah. Despite us talking about non-terminating, but they can be represented as in form of an exact fraction, right?
Yes.
So recurring decimal is also a rational number. Are you together?
Yes.
Good. Now, I want us now to go directly to maybe 1 or 2 application of these stuffs, and then we can start search. I want us to imagine of root 9, right? Root 9. So root 9 is 3 times 3, right?
Yeah.
I can represent it as 3 times 3, right? That is root 9. So I will say root 9 equals to a plus or minus 3.
Plus 3.
A plus 3 or minus 3. What do I mean here? I want you to take a negative 3, that is a root 3, a root 9 can be a positive 3 or a minus 3. I will explain now. Check here. Root 9 equals to 3 times 3. I guess that one you agreed.
Yes.
Root 9 equals to minus 3 times minus 3. You remember integers? A negative times a negative is equals to a positive. I hope we are together now.
Yes.
Thank you. Yeah. So that's why I'm writing here root 9 is a positive and a minus 3. I hope we are together now.
Yes.
Right?
Yeah.
Yeah. So we can say that root 9 is rational. Root 9 is rational. Pass out. So the big question is square root. Or yeah, let me talk about square root. Is a square root a rational or irrational number? Is what we are going to ask ourselves. Are we together? Most of the square root are irrational number. Most of the square root are irrational number. Okay? Because yes, we can get the root of 9, right? We can get the root of 16, right? Giving us an exact number, right? But can we get a root of 17? To give us a decimal, right? This automatically, most of the square root are irrational numbers. So when you get stuff like this one that does not have an exact number, what we are going to do is you give two numbers between which the square root lies. What do I mean? You give two numbers between which the square root lies. For example, I have a number like, let me take a number like 5. I can take a number like, let's look at the ones that do have square root. 9 have a square root, right?
Yeah.
The other one is?
16.
16 has a square root, right? And then 15 has, 25, right?
25.
Yeah, have a square root. Now when I say you give two in between, exact number, a number between two square root. Look at 9. The square root of 9 is what? 3, right? And then for 16 is what? 4. For this one is
5.
5, right? And then we have 36, right?
36, yeah.
And then 49.
49.
Yeah, well, that way and that way, okay? But we have some numbers that don't have a square root, right?
Yeah.
So we need to get the square root. Now, maybe I will do the question so that we can understand what I mean, okay? Now, check here. Now, we are being told, find the integral number between which the root of 137 lies. Find an integral number. Find an integral number. Find an integral number between which root of 137 lies. Now what do I mean here? This is what I was meaning.
Root to 137.
Yeah. Now root 137 is not there. We get decimals when you use a calculator, right? But there is a root before this one, and there is a root after this one. Which is the closest one here?
So that one is probably
The root of 12. 12 times the square of 12. So 140,
144.
144. There is a root there after, right?
Yeah.
And before it is what?
120.
121, right? The root of 11, 121. So what I was saying is in between, you look for the root in between these two. The one that, the closest from the bottom, and the closest from the top. Are you getting now? Now, let's do it together. So the root of 137, you can say, the root of 121 is less than, right?
Yeah.
137, right? But 137 is less than 140. We are together, I hope, right? So, the square root of 121 is less than the square root of 137, right? But is,
More than.
I mean, less than the square root of 144, right? Now, the square root of 121 is what? 11, right?
Yeah.
So 11 is less than, right? We don't have the square root of 137, right? So the square root of 137 is less than the square root of 144, which is 12, right? So hence the square root of 137 lies between 11 and 12. That's what I mean. Something's built here.
Mariano está?
No, it's not.
Bajia ya watu ambao tunakula.
Like bread crumbs.
Haya. Yeah.
What are you talking?
Whoa.
I don't think
Come on,
Yeah.
Shut up,
It's been
Captain.
already, yeah.
give me all money out of it. Ali, ikaw dito kukulay.
Oh, I found it. Can I follow my hatay to agal?
Paano nagsasama dyan ang tawlaw? Ayaw,
Bajia. Wow, really.
Ayaw, yasina.
I found my little minute back away.
Adi, okay. Alam mo na
I found my good girl. Sambus kaya po kare.
So we are good there.
Bawi.
It's okay.
Bawi, naigirta. Naigirta.
You made the link to check, that's why you say so. It's okay.
Don't lock the door.
Okay. Continue, Najib. So, we are okay there? Now let's go to SAT now. That's only a concept I wanted you to have. Oh, it's there, right? There is nothing to practice here, it's just I was building up with. Now let's come to SATs. As we are now where we start now our topic.